Okay, so today I'm going to be running through the process that I have taken with learning SolidWorks and AQWA, ANSYS AQWA, which is hydrodynamic diffraction, frequency domain boundary element method software, and then how I then prepare everything from AQWA to be used in a time domain analysis, whether that's in WEXIM or hydrodynamic response in the ANSYS workbench modules. But I'm going to be kind of going through the process that I took because I know wave energy is a growing industry. And for me, I remember just racking my brain trying to figure out how to do this. And so I just figured I could make a video or two just kind of walking through generally how I did it and some of the some of the things that confused me and got me stuck, and maybe I could just use that to help somebody else. So hopefully you don't run into that issue. So first things first, we'll go to SolidWorks and just click New File. We'll just do a new part file, and you can do a part or an assembly. I'm just going to do a part because in the end we're going to export it as an IGS file, .IGS file. So you can do that in assembly or you can do it in a part file. So I'm just going to do a part file just for now. But the first thing we're going to want to do is we're going to want to define this coordinate axis. So the way AQWA reads it is the x direction, so the x direction, that is going to be the motion of the waves. So the waves are going to go this way. They're going to come from the negative x direction, they're going to go this way. Gravity is essentially a negative z. And so this is kind of the up and down motion. And then this y direction for the oscillating wave surge converter, that's going to be what it rotates around. And so I have a picture here. Let me snip it and then bring it over. All right, here we go. So this is going to be, that's the z direction. This is the direction of the waves. This FSWL, that stands for free surface water level. You might also see it as MSWL, or mean surface water level. And that's basically, this area is water and this area is air, and the free surface water level is just this line. So we're going to be, that's how we're going to define everything, and typically that's in the top plane. So, all right. So top plane, again, remember that it's going to be rotating about the y-axis, and so what we're looking at right now is a side view. And so I'll come over here, I'm just going to sketch, I'll sketch a point on this circle. I'll sketch a circle, maybe radius of, I don't know, 0.12 meters. And also make sure, come down here, that it's in meters, kilograms, seconds. We'll change that a little bit later for exporting purposes if you're going to be exporting an STL file, but right now it's fine. And so then I'll come over here, again, just kind of making an arbitrary shape. This is kind of what these devices look like, just kind of rectangular faces. Smart dimension that to, I don't know, maybe 0.8. I think this is the width of a device that I was working with. But come over here, trim that off. So now we have one body. And then we'll come over to extrude. We'll extrude at 0.5 meters in that direction, and 0.5 meters in that direction. And so here's our device. Right now, the center, the origin is at the very middle in the y direction. And we can check if we go to evaluate and then mass properties. So you have your part, you have your center of gravity, or center of mass, yep. And what we're going to want to do is that picture that I showed you earlier, this one, you're going to want the wave energy converter to be, if it's surface piercing, if this little bit is piercing the surface of the water and then this bit is underwater, you're going to want the origin to be right there at the free surface water level. So let's say I wanted this to be, let me sketch on it. Actually, I'll sketch on the top plane. And so I'll put a point, let's say right here. Smart dimension this. So from from the pivot point to here, we'll make it 0.35. And so now it's going to pierce the surface of the water by 0.13 meters. Okay, so what I'm going to do is I'm going to move this down so that this point is now in line with the origin. Okay, and so I'll come over here to Features, Insert, Features, and then Move Copy. Bodies to move or copy is going to be this guy. And then the direction, we're going to move down in the Z. I think, what was it, 0.35, I think? Oops, sorry, wrong way. Negative 0.35. All right, so now we're down there. And so now that point is still going to be there, but now the origin will be at that 0.35. So now if we go back to the mass properties, I think it was 0.22 last time. It should be that 0.22 minus 0.35, which is negative 0.13. And so that's where AQWA is going to draw the mean surface water level on our device. And I'll go into all of the other the things that we'll be like doing in AQWA a little bit later. But for now, for this video, it's just preparing the geometry. That's basically it. If you want to remove that sketch, totally can. And then you'll just have this single body. We're going to be using these mass properties a lot, though. Another thing I should mention is the density of this material is 1,000 kilograms per cubic meter. That's not really realistic because the density of seawater is 1025 kilograms per cubic meter. And if you have a device whose density is 1,000, then this is going to sink essentially. And so we're going to want the density to be lighter. And so what a lot of papers do, what I've done is come over here to Options, Use Custom Settings. And then usually if density of water is 1,000, density of seawater is 1,025, I'll come over here and I'll change this to 512 because 1025 divided by 2 is 512, so about 512.5. And so change it to that just to make the device lighter so that it will actually float, because whenever the wave strikes it, you want the hydrostatic restoring force, aka the buoyancy force, to pull it back up to equilibrium. And so you want the device to be light enough so that it's buoyant. So change that to, let's say, 512, and see the mass drastically reduces to 32.42. Again, center of mass and everything's here. And we're going to use these moment of inertia values a little bit later. So that's kind of it for the design process. As far as exporting, you're going to want to come over here, click Save As. I'll save it to my desktop. We'll just name it Flap. I'll do Flap. So you're going to want to save it as a part file, and then you're also going to want to save it as an IGS file. And that's what you're going to be importing to AQWA. And so we'll get there in just a second. But right now, that's it. We're done with SolidWorks at this point. The only thing we're going to be doing is coming back. So don't close SolidWorks yet, but keep it open and keep this box open because we're going to be using these values in just a second. So that's it for this first video.